Hello guys, welcome to another video. This one is paper 2-1 of October-November 2011, and this one is for Add Math paper 2. So in this video we are going to be doing all the questions one by one and of course step by step. Now with that being said, let's move on to question number 1. So here we have to solve this question. As you can see, we have modulus on one side and no modulus on the other side. So one way to solve this is to square both sides. That is one way, but we can just do this if you want to. We can write 4x minus 5 is equal to 21, or 4x minus 5 is equal to minus 21. So you will have 4x will be 26, x will be 26 divided by 4, 4x will be minus 21 plus 5, 4x will be, so what is minus 21 plus 5? That will be minus 16. X will be minus 4. So this one we can simplify. So 26 divided by 4, that will be 6.5. So x can be minus 4 or can be 6.5 for question number 1. Now question number 2. Given that the straight line y equal to 3x plus c is a tangent to the curve x plus k in terms of c. Okay, so one thing we know is that this line meets the curve at one point, so they intersect at one point only. So what do you know? When they meet at one point, we know b squared minus 4ac has to be 0. Okay, so now we can solve and then find this, right? So here we have y, here we have y. You will have 3x plus c equal to x squared plus 9x plus k. Now send everything to one side. You will have x squared plus 9x minus 3x plus k minus c equal to 0. Simplify. This will be plus 6x plus k minus c equals to 0. So right now we have, this is 1, this is 0, a, b, and c. So we know b squared minus 4ac has to be 0 because the line meets the curve by one point, which is by a tangent. That's why we know this is true. Now replace the values. B squared will be 36 minus 4 times 1, and times c will be k minus c. Simplify, you will have 36 minus 4k plus 4c equal to 0. So we have to express k in terms of c. So we send k over here. You will have 4k will be 36 plus 4c. K will be divided by 4. You will have 9 plus c. So this is your answer for k in terms of c. And that will be your question number 2. Okay, so now let's move on to question number 3. So without using a calculator, find the value of cos theta, giving your answer in this form, where a, b, and c are integers. So if you look at this, this is a triangle. We know all the 3 sides, and you want to find cos of this angle. So you have to use the cosine rule, right? So cosine of the angle is equal to this side square, which is 2 square, plus 2 plus root 3 square minus this square, and then divide by 2 times this side and 2 plus root 3. So this is only the cosine rule. We have a formula for that, you have to know, and we just replace the values to get this. Now we have to simplify one by one. So let's first find this expansion. So what is 2 plus root 3 square? That will be 4 plus 4 root 3 and plus 3. That will be 7 plus 4 root 3. So for the value on top, what you will have, this is 4 minus 9. So you have 4 minus 9 plus 7 plus 4 root 3. That will be, so 4 minus 9 will be minus 5, plus 7 will be 2, plus 4 root 3. So your value on top will become 2 plus 4 root 3. Now what is this one value? Let's check. So here we have 2 times 2 will be 4. 4, expand this, you will have. So we can first leave this outside. You will have 4 here outside. And then 2 plus root 3. Now we can divide by 2 everywhere. You will have 1 plus 2 root 3 over 2 plus root 3. That will be 1 plus 2 root 3 divided by 4 plus 2 root 3. Okay, so now we have this. We have to express your answer in this form. So we have to multiply. So right now I have 1 plus 2 root 3 over 4 plus 2 root 3. So if you want to simplify this, you have to multiply by their conjugate of the denominator, which is 4 minus 2 root 3 and 4 minus 2 root 3. So let's see what you will have. On top you will have, so we have 1 times this will be the same thing. And then plus, this time this will be 8 root 3 minus 4 times 3. That will become, so 4 minus 12 is minus 8 plus 6 root 3. Right? So 4 minus 4 times 3 will be minus 8. Right? So this is the value on the top. You will have minus 8 plus 6 root 3. Now what is the value on the bottom? We have to check. So you will have 4 square minus 2 root 3. That will be 16 minus 4 times 3. That will be 16 minus the value of, that is 12. You will have 4. So the bottom will become 4. So the reason why I have this, just to explain, is because if you look at this, this looks like a plus b times a minus b, which is equal to a square minus b square. So that's why I write a square is 4 square minus b square is this square. So you will have this for your value here. Now if you divide by 2 everywhere, you will have minus 4 plus 3 root 3 divided by 2. So this is your answer for this question. So cos theta is minus 4 plus 3 root 3 over 2, where the value of a, b, and c are integers. So a, b, and c are integers. That is question number 3. Okay, so let's move on to question number 4. Given that y equal to this equation, we have to find dy by dx. So pretty easy. The first thing I can do is I can send this up. You will have y is equal to x squared plus 3 power minus 1. So from this I can find dy by dx. First thing you have to multiply by the power, which is minus 1, x squared plus 3 minus 1 to the power, then times the inside, d by dx, you will have 2x. That will be minus 2x over x squared plus 3 squared. So k have to be the value of minus 2, according to this question. Now for part 2, hence we have to find this and evaluate this. So hence means we have to use the answer from above. So what did we find from above? So because we know differentiating this will give you this, so it means that if you were to integrate this, it will give you your value of y, which is 1 over x squared plus 3. But now for the question, we want to find 6 here. Here we have minus 2. So how do you eliminate minus 2? You have to divide by minus 2 everywhere you will have. This will become x, this plus 3 square dx, and this will become minus 1 over 2 x squared plus 3. So now we can use this to solve this. Okay, so if you observe 6 is only a multiple, you can take out 6, and on the inside you will have x over x squared plus 3 square dx. Now this will be 6, and this you know already, it is this one. It is minus 1, 2, x squared plus 3, this. So that will be simplified to 1, 3. So you will have minus 3 over x squared plus 3 as your answer. Now if you can write c if you want to, it is up to you, but you don't need in this case because we know the exact value already. You don't need that if you don't want to. Now we have to evaluate this one. You have to find 3, 1, 6x dx. That will be minus 3 x squared plus 3 between the limits of 3 and 1. So simplify. For 3 it will become minus 3. You will have 3 squared is 9 plus 3, that will be 12. Then minus 3 over 1 plus 4, 1 plus 3 is 4. So you have minus 3 over 12 minus 3 over 4, become half. So your answer is half for part 2. And that is your question number 4. So let's move on to question number 5. The functions f and g are defined for x is any real value. So whenever you see x, it means the domain is defined for any real values by f of x and g of x equal to those two functions. Now part 1 is find this value. So first you can find this one. First find g of 4, which is 4 squared minus 1, that will be 16 minus 1, that will be 15. So this will equal to, now this is, you know this is the value of 15, so you just have to find f of 15. That will be 2 times 15 plus 3. That will be 30 plus 3. Your answer will be 33. That is part 1 of your answer. Now for part B, the functions h and k are defined for this domain where x is more than 0. Then we have these two defined for h of x and k of x. Now express each of the following in terms of h and k. The first one is we have root of x plus 4. So now if you observe, we have root here, and here we have x plus 4. So basically we have h of x inside of k of x. So it will be k h of x. Okay, you can check. That will give you k of x will be, sorry, k h of x will become, h here, it will become root of h of x, and that will be root of x plus 4, just as required. Part 1. Now part 2, here we have x plus the value of 4. So now if you observe, we don't have any square, no square root here. We only have x but plus 8. So we have to add 4 again. So if you observe, we can just do h square of x, which is h of x. That will be h. So it will equal to h of x plus 4. H of x is x plus 4 plus 4. That will be x plus 8. So your answer will be h square of x. So now for this one, we have x is equal to x squared minus 4. But here we have square and minus 4. And here we have plus 4, and here we have square root. So if you observe also, we know from part 1, we have this. K h of x is equal to root of x plus 4. So here we have root, here we have square root, plus become minus. So from observation, you can see that it has to be the inverse of this one. Let's try. So let's first let y equal to this. So you have to make x become the subject. You will have y squared. X becomes y squared minus 4. So exactly, you can see we have proven that k h, the inverse of this function, will be x squared minus 4. So this is inverse of k inverse. Okay, and that will be your answer for question number 5. Move on to question number 6. So the solutions to this question by drawing will not be accepted. So we have to do one by one. So we have the points A, B, C. D are vertices of a trapezium, okay, in which AB is parallel to DC and angle BAD is 90 degrees. We have to find the coordinates of D. So we can make a drawing so we can understand what's happening. So let's say we have a point, it's a trapezium where AB is parallel to DC. So we have, let's say AB is here. Is parallel to DC. Okay, and then we have angle BAD. This is A, this is B, this is D right here is 90, and this is C. So you will have BACD. So BAD is 90, and we have AB is parallel to DC. Okay, and then we have the points 3, 8. C is 13, 13. D we don't know. X, Y. A is 1, 4. For example. So this is not the exact shape. It is approximately something like this, so you can understand what's happening. Now we have to find the value of D. So how can you find D? So one thing we can use here is the fact that they are perpendicular. So distance AC and AD are perpendicular to each other. So what do you know? That the gradient will be, product will be -1. We can try, right? We don't know what to do yet. We can try to see what is possible to find. So first equation we can have is, let's find the gradient of AB. So you will have y2 minus y1 over x2 minus x1. You will have 4 over 2, that will become 2. Now we can find the gradient of AD, that will be 4 minus y over 1 minus x. So this is your gradient of AD. So now something we know is that because it is perpendicular, we know that the product of their gradients have to give you the value of -1. So we can form an equation. So 2 times 4 minus y over 1 minus x has to be -1. So solve this, cross multiply, you will have 8 minus 2y is equal to x minus 1. So you have, let's make x become subject, so x will be, so we send this over here, you will have 9 minus 2y. This is your first equation based on those information. Now what else can we find now? Now because these two sides they are parallel, we can form an equation. We can say that DC is equal to m times AB because they are parallel to each other. So let's see what we have here. Okay, so AB is given by OB. So OB minus OA, so 3 minus 1 is 2, that will be 4. And DC is, this minus this will become 13 minus y, and 13, sorry, minus x minus y. So here we're going to have a few equations. So we have 13 minus x will be 2m, and here we have 13 minus y is 4m. So we have a few equations we can try to solve. Now what else do we have? So here we have something. So let's try to replace this in this. You will have 13 minus x will become 9 minus 2y is 2m. So you have 13 minus 9 plus 2y is equal to 2m. Now 13 minus 9 will be 4. Let's check. 4 plus 2y is equal to 2m. Divide by 2 everywhere, you will have 2 plus y is equal to m. So this is your equation for m in terms of y. Now replace m in this m to see what happens. So you will have 13 minus y. 4 times m will be 2 plus y. You have 13 minus y is equal to 8 plus 4y. So now we can send this over here. You will have 5y is equal to 13 minus 8. So 13 minus 8 will be 5. So y has to be the value of 1. Okay, so m will be 2 plus 1 will be 3. So x has to be 9 minus, or 2y, so 2 times y. That will be 9 minus 2, that will be 7. So you have found your point D, which is 7, 1. This is your point D, and as you can see, we did this step by step. Okay, so that will be question number 6. Now let's move on to question number 7. Given that tan x is p, we have to find, in terms of p, cosec square x. So here in this case, we have to use the triangle to help us to find those values. So let's draw this. We have a right angle triangle, right? And this is tan x. I said this is x. This is right angle. So now you know tan is what? Tan is x. It is your opposite side over your a side. So here we have p. P is p over 1. Your o side will be p. Your a side is 1. So what is this side? Let's find the h side. Here will be h square is p square plus 1 square. That will be h square plus 1 plus p square. So h will be square root of 1 plus p square. This is 1 plus p square by your Pythagoras theorem. Now for you to find cosec square x, you have to know what is cosec x. It is 1 divided by sin x, right? And what is sin x? Sin x is defined by your opposite side divided by your hypotenuse, which is O is p divided by hypotenuse will be 1 plus p square. Okay, so from this you can derive cosec has to be 1 over this, so it will become root of 1 plus p square over p. So now you want to find the value of cosec square x. That will become 1 plus p square over p square. Okay, so this is your answer for part A. Now for part B, we have to prove the left hand side becomes the right hand side. So step by step. First, what is sec theta? Sec theta will be 1 divided by cos theta. Now we can divide, we can expand. So 1 times this will become 1 minus cos x, theta, and this time this will become plus 1 over cos theta minus 1, right? So these two will cancel out. So you will have 1 over cos theta minus cos theta over 1. So now we have to simplify 1 by 1. So first, let's make it become the same base. You will have cos theta, so you have 1 minus cos square theta, which is equal to sine square theta over cos theta. Now if you simplify this, sine square is sine theta times sine theta divided by cos theta. Now you know that sine theta over cos theta has to be, so this is the same, this will become tan theta. So this is shown as required for this one. This is your question number 7. Let's move on to question number 8. So here we have a shape which is OABXP, Okay, so OA is A, OB is B, as you can see, and then AP is 2 over 5 AB, so which means AP is 2, AB is 5, which means PB is 3. Okay, now part 1, given that OX is mu OP, okay, where mu is a constant, express OX in terms of this. So first let's find what is OP. Okay, OP will be O going to P. That will be O going to A going to P. Right. So OP will be O going to A plus A going to P. So OA is A and AP is 2 over 5 AB. Now we have to find AB. AB is found by what? By AO OB. That will be minus A plus B. So that will be A plus 2 over 5 minus A plus B. That will become A minus 2 over 5, A plus 2 over 5, B. That will be, this is over 1 of course, you can simplify, you will have 3 over 5A plus 2 over 5B. So in the end, we have OX is mu times OP. That will be mu times this. That will be 3 over 5 mu A plus 2 over 5 mu B. That is part 1 of the question. Now for part 2, given that also AX is this times OB, where this is a constant, use the vector method to find the value of mu and this one. So yeah, so we just have to find this. Where is OB? OB is this, it is B. So we have AX is what? Is OX minus OA is equal to mu times OB. Now we just have to replace the values. OX is found by this one, which is 3 over 5 mu, 2 over 5 mu for B. So we can write this down in this way just to help you as well. It's okay, but you don't need to do that. You can just do regular way. Let's just do it regular way, which is this one. 3 over 5 mu A plus 2 over 5 mu B. OA is minus A is equal to lambda OB is B. Okay, so now we can simplify. We can just compare the coefficients. We can send this over here. You will have 3 over 5 mu A plus 2 over 5 mu B equal to A plus this times this. So the coefficient of A is 1 and the coefficient of B is mu. For this one, coefficient of B is this and this is for A. So from this you can see we can have 3 over 5 mu is equal to 1, which means mu is equal to 5 over 3. Now here we have 2 over 5 of mu, which is 5 over 3, is equal to lambda. So cancel, cancel, which means lambda has to be 2 over 3. This is your answer for these two values. That is your question number 8. So let's move on to question number 9. The table shows some values for x and y. Okay, now part 1, we have to complete this table. So we have to find these values. So first one is x root of x, so 1 root of 1 will be 1. 2 root of 2 will be 2.83. 3 root of 3, that will be 5.20. 4 root of 4, that should be 8. And then 5 root of 5 will be 11.2. Now for this one, it is y root of x. Y is 3.4, root of 1, that will be 3.4. Then we have 2.92 root of 2, that will be 4.2. 1, 3. That's fine. And we have for this one is 2.93 root 3, 5.07, and then we have 3.1 root of 4, that will be 6.20, and 3.34 root of 5, that will be 7.47. Okay, so now we have those two values. We have to plot the graph on the graph. So let's do this. So the first point we have is 1, 3.4, so 1 will be here, and 3.4 will be right here. And then we have 2.83, 4.13, so 2.83 will be somewhere about this point. And then we have 4.13 should be somewhere about here. And then we have 5.2 will be 5.07, 5.2, 5.07, somewhere over here. And then we have 8, 6.2, so 8 will be here, 6.2 will be this one. And then you will have 11.2 and then 7.47. So 11.2 should be right here. And then 7.47, 47 should be around this value. Okay, so now we have to join these points by a straight line. Let's try your best to make a straight line. I don't have my ruler with me, so I'll try with my pen. So let's try, that should be this direction. So it should be a line of best fit. So okay, so it seems to be pretty fine. This is my line using the pen, and I can see my y-intercept as well, which is this point. Pretty good. This is my answer for part 2 of this question. Now part 3, use a graph to estimate the value of a and b. So as you can see here, we have the values of a and b. If you observe, we have to first change that into this function. Right. So how can you do that? You must first multiply by root of x everywhere. So multiply by root of x, you will have y root of x is equal to x root of x, value of b, and then you have plus the value of a. So this is your y-intercept, and this is your gradient, as you can see, because here we have your y, this is your x, this is your gradient, and this is your y-intercept. So a will be your y-intercept. If you observe here, that will be this value, which is 0.3. So a, according to your graph, will be from the point 0.3. So a will be this value, which is 3, your y-intercept. And for b, b is your gradient. So let's use 2 points to find the gradient. So we can use this point, and then we can use, let's use this point, which is 5 and 5. Now b will be y2 minus y1 over x2 minus x1. That will be 2 over 5 will be 0.4. So here you go. According to my graph, a will be 3 and b will be 0.4. Now for part 4, we have estimate the value of y when x is this value. So going back to your equation, we have y root of x is 1.5, equal to 1.5 root of 1.5. b, the value of b is 0.4 plus 3. So you have 1.5 root of 1.5 times 0.4 plus 3 divided by root of 1.5. So y will be 3.05. This is my estimation for the value of y. And that is your question number 9. Let's move on to question number 10. So we have a equal to this, b equal to this. So 2a minus b will be, first send the 2 inside, you will have 6, 4, 2, minus 10. minus b will be 1, minus 2, 4, and 3. So you will have 6 minus 1 is 5. This will be 2 minus 2 will be 4. That will become minus 13. That is part 1. Now for part 2, if I had to find BA, B will be 1, minus 2, 4, 3, times A will be 3, 1, 2, minus 5. Of course, rows by column. So 1 times 3 plus 4 times 1, that will be 7. And you will have 1 times 2 plus 4 times minus 5, minus 18. Now for this one, minus 2 times 3 plus 3 times 1, that'll be minus 3. And then we have minus 2 times 2 plus 3 times minus 5, that'll be minus 19. So this is your answer for part 2 of this question. Now let's move on to part 3. We have to find A inverse. So we are given that A is given by this matrix, right? From part 1, you know A is 3, 1, 2, minus 5. So to find A inverse, we must first find the determinant of A. So that will be cross multiply minus 5 times 3 minus 1 times 2. That will become minus 15 minus 2. That will become minus 17. Now we have to find inverse. We have to find the adjoint matrix of A, which is given by, we have to switch the position, minus 5, 3, and switch the sign, become minus 1, minus 2. So A inverse will become 1 over minus 17. So become here, times minus 5, minus 1, minus 2, and 3. That is your value for A inverse. Now for part 4 here, it says use your answer from part 3 to solve this question. So if you observe, we can rewrite this down as matrix. That will be 3, 1, 5, so 2, minus 5, times xy to get 2, 3, 1, 9. So now we want to find the value of xy. We want to eliminate this. This is A. You have to pre-multiply by A inverse on both sides to eliminate this. So you will have xy is equal to A inverse is minus 1 over 17 times minus 5, minus 1, minus 2, 3 times this, 23, 19. So rows by column, minus 5 times 23 plus minus 2 times 19. That will be minus 153 divided by 17. That will be minus 9 times minus 1. That will become 9. Then we have rows by column, minus 1 times 23 plus 3 times 19. 34 divided by 17 times minus 1 become minus 2. So your answer will be xy will be those two values. So you can see x has to be 9 and y has to be minus 2. Okay, and that will be your question number 10. Let's move on to question number 11. So here we have solved this equation. Solving means to find the value of x. So how can you find the value of x? So we have to observe to see what we have. So here we have 5, 25, 25, and 125 for the base. Now you realize that every number here is a multiple of 5. So what do I mean? I mean 25 is what? It is 5 power 2. 125 is what? It is 5 power 3. So let's replace those values by these values in the main equation. So here it is the same, 5 power 2 plus 3. Okay. Now divide by 25 is 5 power 2. So 5 power 2 times 2x equal to 5 power 2 times 2 minus x divided by 5 power 3 times x. So now we can solve this equation step by step. So let's simplify each side. So for here we can simplify. So we have 5 as your base. They are the same for both, so we can bring this up. So you have 2x plus 3 minus 4x equal to 5x, expand the brackets, you will have 4 minus 2x, and you bring this up, will become minus 3x. So now because the base are the same, we can cancel the base. You will have 2x minus 4x will be minus 2x plus 3 is equal to 4 minus 5x. So now we have to simplify. Send this one over here, you will have minus 2x plus 5x equal to 4 minus 3. That will become 3x will be 1, x will be 1 over 3. And this is your answer for part 1. Now for part 2, we have to solve the equation again. Solving means to find the unknown, so find the value of y. So here we have the same log. We can combine them together. So you take log of y plus becomes multiply, this one, equal to the value of 2. Now what is log, right? It means log to the base of 10. So replace, you will have log to the base of 10 is y minus 15 equal to 2. Now you want to eliminate this log value. So we have to send this to this side. You will have this minus 15 equal to 10 power 2. So now we can solve. Expand the bracket, you will have y squared minus 15y equal to 100. Let's send everything to one side. You will have y squared minus 15y minus 100 equal to 0. Now we can factorize. Let's see what happens. So y squared is y times y. And for 100, what are the factors of 100 that you know? We know we can do 20 times 5, right? It will be 100. So let's use that. So 20 times 5, and we need minus 15. So to get minus 15, we need minus 20 and plus 5. So y will be minus 5, y will be 20. So these will be the values of y. Now you have to choose, because if you observe, y will be placed in here, and you have to know that logarithms cannot take negative values, so because of that, this will be rejected. So you have only one value of y, that will be 20, as your answer for y. That is for part A. Now for part B, without using a calculator and showing each stage of your work, find the value of this one. So let's see, what can we do? So first thing we see, they all have the same base, so we can try to simplify them. So one by one. So what is this one? So here we have 2. We can send the 2 up. You will have log 12 4 power 2. Here we have minus, but we can sum this one up. You will have log 1281 power half. And here we have 4, so same steps. You have log base 12 3 power 4. So now we have to simplify. So what is 4 power 2? 4 power 2 will be 16 minus log 12. 81 power half will be 9 plus log 12, and 3 power 4 will be 81. So this is basically power half is square root of 81. That will be 9 for this one. Now we can simplify because they are all the same log of base 12. We can bring them together. So that will be log 12. So first we have 16 minus become divide by 9, plus become multiply by 81. So simplify. You will have, this will go away. It will be 9. You have log 12. And what is 16 times 9? That will be 144. So now you observe, what is 144? It is 12 square. So you will have log base of 12 square. Now for the power, we can send the power to the beginning. You will have 2 log of 12. So now this value, because it is the same, it will become 1. So your answer is 2 times 1, that will be 2. So your answer will be value of 2 for part B. And I think that's your question number 11. Okay, so let's move on to question number 12. Answer only one question in the following. So in this question, we have two choice. We have two options. We can choose this question or this first one. But of course, I will be doing both of them. Don't worry. So let's move on to this one. So here we have what? We have a curve. This is the curve, as you can see here. And we have the tangent to the curve at this point. That's the tangent to the curve. And this line here, it goes through the point P. It meets the x-axis at A and the y-axis at B. So we have these 2 points, which is cut by the tangent at the point P. Okay, that is good to know. And the normal to the curve at point P meets the x-axis at C and the y-axis at D. Okay, so normal and tangent, so this has to be 90. Okay, that's the first thing we can realize, right? Now part 1, we have to find in terms of ln 2 the coordinates of A, B, C, and D. So we have to find these points A, B, C, D. So first thing first, to find those 2 points, to find AB, you must first find the equation of the tangent, right? And then we can find these two. So how would you find the equation of tangent? So first you have to find the gradient of tangent. So let's label this as T. This is normal, right? So to find gradient of tangent, you first have to find dy by dx. So let's do that. So let me use this new page. So we know y is given to you by ln x plus 1 minus ln of x. Now we have to find dy by dx. So dy by dx, first one will be 1 over x plus 1 minus 1 over x. So we are given the point P is given by 1 and ln 2. This is your x and y value. So we have to find dy by dx at the value of x equal to 1. That will be 1 over 2 minus 1. That will be minus half. So from here we have found the gradient of tangent, which is equal to minus half. That's the first thing we know. But now we have to find the equation of tangent. So we know the passing point, we know the gradient, we can find the equation. So equation, that will be y minus ln of 2 over x minus 1. That will be minus half. Now we have to cross multiply. You have 2y minus 2 ln 2 minus x, so equal to minus x plus 1. So 2y equal to minus x plus 1 plus 2 ln 2. So this is your equation of tangent. Okay? So once you have the equation, you have to find the points A and B. A is on the x-axis and B is on the y-axis. So let's do that. First, let's find the point A. It is on the x-axis, and what do you know? At the x-axis, you know the value of y has to be 0. That will be 2 times 0 equal to minus x plus 1 plus 2 ln 2. So x will be 1 plus 2 ln 2. So the point A has to be 1 plus 2 ln 2 and then 0. That is your point A. Okay, let me just circle this as my first answer, the point A. Now I need to find the point B. The point B is on your y-axis, and you know on y-axis the value of x has to be 0. So you will have 2y minus 0 plus 1 plus 2 ln 2. So y has to be half plus ln 2. So here you go, you have b. X is 0 and half plus ln 2. That is your point B. Okay, so that's the first two things we have found, the points A and B. Now we have to find the points C and D. So C is the point where the normal meets the x-axis and D is on the y-axis. So first you have to find the equation of this normal. So you know the gradient of tangent is equal to minus half, as you have seen here, minus half, right? So from this we can derive the gradient of the normal has to be 2, right? Now we can find the equation of the normal. We have the point here, which is 1 ln 2 x and y. So y minus ln 2 over x minus 1 is equal to 2. Cross multiply, you will have y minus ln 2 is equal to 2x minus 2. So y will be 2x minus 2 plus ln 2. That is your equation of your normal. Now to find the point C is on the x-axis. Again, what is true? We know that y has to be 0 on the x-axis. Replace, you will have 0, 2x minus 2 plus ln 2. Now we can send these over here. You will have 2 minus ln 2 equal to 2x. X have to be 1 minus half ln 2. So from here you can see we have C is 1 minus half ln 2. That will be 0. This is C. Now we have to find D. D is on the y-axis. So again, same steps. You would say on y-axis, what is true? The value of x has to be 0. So replace back in your equation. You will have y is 2 times 0 minus 2 plus ln 2. So y will be minus 2 plus ln 2. So this is the point D. D will be x is 0, then minus 2 plus ln 2. As you can see, we have found all the points A, B, C, and D. This is all we need for this one in terms of ln 2, right? That is your first answer. Now next question is, we have to what? We know this is the ratio of area of triangle BPD and area of triangle APC equal to 1 over k. We have to find the value of k in terms of ln 2. Okay, so first, how do you find the areas of those two triangles? So there's many ways to do that. I think the best way I can do is use a formula. It will be much simpler for you guys, right? So let's do that. So first, let's find the area of triangle BPD. So we have the points. The B is here. P is given to you by 1 ln 2, and D has been found to be 0 and minus 2 plus ln 2. And let's take B as well. B is here. So to find the area, we can use the array formula, which is half modulus of the first point, which is B. That'll be 0 and then half plus ln 2. And then we have P. P is 1 ln 2. And then D, we have 0 minus 2 plus ln 2. And then you have to end with the first point. So you begin with the point, you have to end with a point. So half plus ln 2. Okay, so now we have to multiply. First, we have to do in this direction. Okay, so 0 times this will be 0, plus this time this will be this, and that will be 0. So your answer will be half, and you will have only this one, which is minus 2 plus ln 2. Because this will be 0, this will be 0 as well. So there's no use to multiplying these two. Now we have to multiply in the other way, which is this one. So minus bracket half plus ln 2. And this will be 0. Right, you can see this time this will be 0, 0. So there's no use. Now simplify. Half will be half outside. Here we have minus 2 plus ln 2 minus half and minus ln 2. As you can see, these two will cancel out. So you have half. And here we have minus 2 minus half. That will be minus 2.5. But it is inside the modulus. Area cannot be negative. So you will have divide by half by 2. You will have minus 1.25. But it is inside the modulus. It will become 1.25 for the area of triangle PBD. That's the first part. Now you have to find the area of triangle APC. So let's find that. So let me just go here. So we know the points. Let me write down the points first. So we have triangle APC. Let's see what is A again. A was given by 1 plus 2 ln 2, 0. So let's write this down. 1 plus 2 ln 2, 0. And the point P has been given to you by 1 ln 2. And C has been given to you by 1 minus half ln 2, 0. So now we can find the area of triangle APC by using your formula. So area will be half modulus, the first point is 1 plus 2 ln 2, 0 will be here. And then we have this one, 1 ln 2. And then 1 minus half ln 2, 0. And then we can finish with the first point. So when you begin with the point, you have to finish with the same point. Okay, first we have to multiply in this direction. Right, so you will have this time this will be 0, 0. So you have only one thing left, which is this one. Have ln 2, 1 plus 2 ln 2. And then multiply in this direction. So this will be 0, 0, only one thing. We have ln 2, 1 minus half ln 2. Okay, so now we have to simplify. Let's see what happens. So we can factorize these two outside. You have ln 2, you have 1 plus 2 ln 2 minus, become minus 1 plus half ln 2. So simplify the inside value now. So here what do we have? Here we have 1 will go away. And here what do we have else? Here we have 2 plus half. That will be 2.5, so you'll have half ln of 2.5 ln 2 square, because we have ln 2 times 2.5 ln 2. Now simplify, that will become 1.25 ln 2 square. Okay, so now we have to simplify the values. Go back to your main equation here. You can see that area of BPD over area of APC is 1 over K. So let's write this down. So from the question part 2, we have the area of PBC, triangle PPD, over triangle APC. That was 1.25 over 1.25 ln 2 square is equal to 1 over K. So we have to find the value of K in terms of ln 2. So let's see what do we get. These two will cancel out. You have 1 here. Cross multiply K is equal to ln 2 square. And this is your answer for question 12 for part 1. Or we can try to do this question. A curve has the equation y equal to this one, right? And the curve has a point which is stationary at P. Now find in terms of E the coordinates of P and find the nature of this point. So let's do this, pretty easy. So we have y as the equation of the curve. Y is equal to x exponential x. So we have to find the stationary point. So you guys know already at stationary point what is true. dy by dx have to be 0. So let's find dy by dx. So dy by dx will be, this one is a product, so you have to use the product rule. First you have to write down the first one as it is, then multiply by d by dx of this one will be the same thing, plus the second one as it is, multiply by d by dx of the first one will be 1. So you will have x exponential x plus exponential x. Now we have to equate that to 0. So first thing, factorize. X plus 1 will be 0. exponential x equal to 0, or 1 plus 1, x plus 1 will be 0, x will be minus 1, and this will be rejected because if you check, ln of 0 is error, so it would not be possible, not valid. So only this value is good. Now find the value of the value of y will be x is minus 1, exponential minus 1. That will be minus 1 over exponential. So the point P will be minus 1 over e. That is your point P. So now we have to find the nature of this point. To find the nature, we have to find d2y by dx2. So d2y by dx2 will be d by dx of this function. So this give you the same thing. You will have this, and this give you the same thing. So you have exponential x plus 2 exponential x. Okay, so now we have to find the nature. We have to replace the value of x by minus 1. You have minus 1 exponential minus 1 plus 2 exponential minus 1. That will become 1 exponential minus 1, which is 1 divided by exponential, which is a positive value. Let's check. So it is a positive value. So because of that, because d2y by dx2 is more than 0, we say P, which is this point, is a minimum point because it is a positive value. That is for part A. Now let's move on to part B of this question. The normal to the curve we have at the point Q, we have a new point now. It meets the x-axis at the R and the y-axis at S. Now find in terms of E, the area of triangle ORS. So pretty easy. So if you think about this, we have the axis, right? This is x and this is y. Now we have this curve. For example, we have this curve going in this direction. Let's say it's going this way or this way, for example, right? Now we say that this at the point Q, which is somewhere about this point, the normal to this point will be a line in this direction. For example, normal to this point, and this line will cut this and this 2 point. So this is the point R and this is the point Q. This is O, so we have to find the area of this triangle. But first we have to find the point R and the point Q. But first we need to find the equation of this normal line. Okay, so to find the equation of the normal line, we must first find the gradient of the normal line. So first we must find the gradient of tangent, which is dy by dx at the point of x equal to 1, because the point Q is 1 exponential. So you will have 1. Replacing dy by dx, you will have 1 times exponential. X is 1, right? So plus exponential 1. That will be 2 exponential. Okay. Now from this you can find the gradient of normal. That will be minus 1 over 2 exponential. Now from this, y minus exponential over x minus 1 is equal to minus 1 over 2 exponential. So now we have to cross multiply. That will become 2 exponential y minus 2 exponential square is equal to minus x plus 1. So this is your equation of your normal. But you have to find your points, which is point R and the point S. So point R is on the x-axis, right? So we know the y value will have to be 0. So let's do that. Replacing, you will have 2 exponential y minus 2 exponential square is equal to minus x plus 1. So this will be 0. So that will cancel out. You will have x have to be 1 plus 2 exponential square. So your value of R will become 1 plus 2 exponential square 0. Now let's find the point S. S will be at the y-axis, and that is true when x is 0. Replace in your equation 2 exponential y minus 2 exponential square is equal to minus x plus 1, and here we have x as 0, so you will have 2 exponential y will be 1 plus 2 exponential square, so y will be 1 plus 2 exponential square divided by 2 exponential, so s will be 0, 1 plus 2 exponential square divided by 2 exponential. So now we have to find the area of triangle OSR. If you observe, this is y. They seem to be positive values, so basically our normal will be in this direction. This is your point R, and this is the point S. This y value here is 1 plus 2 exponential square over 2e, and this x value here is 1 plus 2 exponential square. Now to find this area, you observe it is simply a right angle triangle, half times base times height. So you will do half times base is this one, which is 1 plus 2 exponential square, times height, which is 1 plus 2 exponential square divided by 2. Now you can simplify, that will give you 1 over 4 exponential times 1 plus 2 exponential square. These two are the same. So this can be your answer in terms of E for question part 2. And that will be the last question of this paper. I hope that was somewhat helpful. As always, thank you for watching. I will see you soon.